8, 7, 6, 5, 4, 3, 2, 1. Trick shot. Hi, the message says. Fire the probe with any integer velocity in the x forward and y. Initial velocity 10 times would look like that. If we fire this probe straight up, well, that would fire the probe forward at a slight downward angle. Yep, I understand. As my position starts at 0, 0. Okay. Then we'll follow some trajectory by moving in steps. And each step will occur in the following order. Its x position increases by its x, its y increases by its y. The drag the probe's x velocity changes by 1 towards the value 0. Decreases by 1 if it's greater than 0. Increases by 1 if it's less than 0. So change is already 0. Due to gravity, the probe's y velocity decreases by 1. Okay. For the probe to successfully make it into the trench, the probe must be on some trajectory that causes it to be within the target area after any step. The submarine computer allows already directly in this target area. Your puzzle's input. The initial xy velocity value such that after any step, the probe's x position is at least 20 and at most 30, and the probe's y position is at least minus 10 and at most 5. Yeah, I understand. Yeah. Yeah, that's not too bad. I can do that. I can easily do that. So, okay. First of all, let's delete everything. So, okay. So, and so on and so forth. So everything starts at... no, that's not going to work, is it? Okay. So what we have to start doing is combine them. It start at 0, 0. That's 1. Okay, that's how we're going to do this. Okay. So, so what's a minimum that we need to have? If we want to reach at least 57, and it continually decreases, whoops. Oh, come on. You have x of at least 11, so it needs to start at least 11. So we're going to have this be 11, 12, so on and so forth. Yeah, because otherwise you wouldn't get enough x speed to even make it to 57, because it slows down to eventually where it's just a free fall. Okay, so we go down to there. I mean, may as well start simple. Equals column divided by 2. I'll spell column correctly. Yeah, so let's take that, drag that out to, let's say, 1,000. So we have equals 500 be a big number. Then we can take that, drag it out to be there. Then we take this, drag it down to like 500 as well. There we go. So let's do it like this, actually. Make it a little smoother. Pop it over 1. There we go. Let's do it like this. There we go. Perfect. So here we have a y of 500 and an x of 509. Now, there's probably going to be wind in the next part. So what this is going to be, it's going to be... Well, actually, what I'll start by doing is I'll take that, hide. I'll just do this for unhide. There we go. So we've got a couple different examples here. Then I'll come down here and hide all those. So that's one case. No, unhide. There we go. Go all the way down to here. All the way back to here. Okay. So we're going to start with this as our sample. Just think outside borders. I mean, 500 is obviously too far. X only never needs to go to 116. So let's just do, for the sake of convenience, let's just go up to 130. There we go. Perfect, the outside border. And now we can go... So that's one set. I'm going to take from here, there. Delete, just get rid of the hidey rows. So I'll start by taking this guy. Yeah, let's do this, paste it here. I will take this, paste values, and this is this, and it's 1. All the way up here. And now this equals max of 0 and that minus 1. Ba-da-dump. So this is current position with its current velocity. Equals that plus that. And now we say if the x value is greater than 116, you stop. We'll have a check down here for each of those. So yeah, let's do... So I'll put that in the box again. Oh, actually... These columns are 1001 cross. If you subtract 1001, so it's going to be 2. Plus 1000? I think that's right. Looks right to me. Oh, except when you get all the way up here. It's column minus 1. 1 plus 1001. Now this guy's a little bit easier to do. Equals this plus that, but a row isn't minus 1, row just is 1. And then we'll have a little catch table here afterwards. Whoops, actually, so what I'll do is I'll do it like this. But we will just do this, paste values, and then I'll erase these formulas. Paste values. Paste values, there we go, like that. And now, if that greater than or equal to 57, less than or equal to 116, and that is greater than or equal to minus 198, and that is less than or equal to minus 148. We do or that or that. I don't even need to, yeah, I can just do that. That should just work. So it's going to say false right now. But all these are going to say false. But here, I will paste formulas. And now, I can just... I think I can just copy over. I think I'm gonna start plummeting. Let's go a couple hundred iterations out. But eventually we'll reach a point where yeah. Well, in order for x to be less than 116, so start at 15. Oh, it could be higher if it shoots very briefly. But it wouldn't, but then that won't be very high. I think we're looking between 11 and 15. We'll do just a couple iterations here. So what I'll start by doing is shrinking these. These I'm just going to get significantly larger. But yeah, I'm just going to shrink all of these, I think, to like 30 pixels. Uh-oh, nope. 30, 30, 30, 30. Let's do it like this. There we go. They are now shrunk to 30. So now I can take all of these, copy, paste. Uh-oh, that's thinking a bit harder than I would like it to. Yeah, since I was okay, yeah. So I think values above 20 will not be correct. I'm actually going to gamble on that. I think based on my interpretation of the question, values under 20 will not be the correct answer. For x values under 20. So I'm just going to completely abandon that mathematical... And hey, there could be values in the 500s that'll end up working. I don't know. But yeah, eventually it'll be a straight fall, and then it'll just zoom right past for several numbers. But there could be a ridiculously large y, right? Yeah, because eventually it'll just reach x equals 0. Yeah, it'll eventually reach x equals 0. Which we're just gonna reach, like, shortly. It shouldn't take long at all, actually. What? Oh my gosh, wait a second. 1,000 apiece. What's the farthest this goes? It goes to 16,000, right. Okay, well, let's solve this through another method, which is... What? What do you mean it's not the same size? Okay, well, I'll take these, or I'll actually take V's. I'll paste transposed. None of these have proper that. So we'll start by, yeah, that's the X. Oh, wait a second. The heck was this? Well, now this replaces column with row. Okay, let's just take this. Scroll all the way back up again and fix this. So this is the x velocity. That's the y velocity. This is the checksum table. Broop. The heck? Did I not? Oh, I didn't do this correctly. Yeah, well, I think that the initial value should only be 20, so I'll just delete that. That works fine. Okay, now we do this. Outside border, okay. I need a thick outside border. Okay, stuff's beginning to work out now. This is that. That is that. That works out correctly. We do 0, 1, 2. I go all the way down. 500. I'll just hide to there. Let's just hide. Okay. That is boxed. Yes, there we go. Okay. Turn to get this now. Okay. Ba-da-da-da. Da-da-da. Ba-da-da-da. Yep. And now we're getting to the point where the x's are going to start getting low. Then once all the x values are 0, we can start evaluating. So, all the x values are zeros. What I can do at this point is actually, first of all, are there any true values? There's literally none. Okay. So, using the wimpy y values. Well, because we want to have positive y values. So this doesn't matter, actually, at the moment. We've now reduced it all to x's are no longer changing. Yeah, x's are no longer changing. Oh, the indirect is wrong. Yeah, because it's... So row minus, yeah. Should be the same thing. It's just going to fix all those x values. So yeah, all of these x values should be the same. So, know which of these x values are within range. I can just manually purge them. X value goes up to 116. Shift cells left. That's the first one that we have. Minimum 57. That works. Okay, but these all... Yeah, okay. So, max 116. These guys all overshoot. Shift cells left. 116. It's exactly in 116. That works. $116 misses here. All the other ones work. Okay. Now we have our data set. These are going to be all the ones that I think are going to possibly hit. Now we have to get exactly between 198 and 148. Okay. But yeah, now we can keep going beyond there. Wait a second. If we're shooting up, and it reaches a zero velocity, eventually it'll reach the exact same point again. Just goes down at a faster value. So the best value starts at S, 0, goes down to 198. So yeah, it's 198. So we're adding all the numbers from 198 up. Right? Yeah. That's be right. Yes, it is. Yeah, because we have some velocity that eventually slows down to whatever value at an x value. An x speed will eventually reach 0 and just start plummeting downwards at an increasing accelerating speed. But they will always hit the exact same and reach here. Oh, at 1 higher. Yeah, so it goes at a 1 higher than the base value. What our base value was here. Which means this goes 1 higher, we need 1 less than 198. So that's correct. Okay. Oh, we need to find every initial velocity that caused the probe to eventually be within the target after the step. There are how many single initial velocities cause the probe to be within the target area after any step? Okay. So, any initial velocity that reaches 0 and then is a value that gets us between those areas. So, we can take any velocity from 11 to 20. So we have 10 different values, because if we have 21... Yeah, well, oh gosh, every possible velocity? That's going to be a little screwy. But the highest velocity we have to go to is 198? It's the biggest number we can go to. We might have to go down. Well, there's the obvious start. But then everything beyond there would be lower. So let's actually tailor these values a little bit. First of all, let's just take these. Yeah, I just did this mathematically in my head. I don't know why I had to use Excel for this. Delete. Yeah, that's something that you can just mathematically perform. Let's first of all scroll all the way down. Whoops. Here we go. 199 is not a value that we need to start with. We only need to go to 1. Like, let's just say 200 for the sake of convenience. That's the highest possible velocity we could possibly do that would work with this. And now we have to do all the other velocities that will eventually reach in that range. So 20 will reach there because 20, 19, 18 has values that eventually reach there. Also, I'm going to go from 2... hide. Perfect. That's better. So much better. Oh, phew. So then 21 would reach. Let's just actually... We actually say how many steps is going to reach for each one of those values, then say what numbers would reach that number of steps. Ba-da-da-da. Yeah, which values reach the bottom, though? Because 14 plus 13 plus 12 plus 11, 10 plus 9 plus 8 plus 7 plus 6 plus 5, which is 105. Which is fine. So 14 works. And we'll get all the way down to 57. 13. 12. 11. 11 would work. So we need to get to... So the velocity needs to be at least 11. So 11 to 14 will all reach a null state. So you have the most amount of values to care about here. These guys won't reach a null state and will eventually overshoot. We need to figure out how many steps it takes to overshoot that x value. And then from there we say how many of each y value will eventually reach exactly that number. Most big y values will occur in this range here, but there's a couple of them that matter in these. So, first of all, how many steps does it take to get to do it with 15? Well, how am I gonna do this? Okay, so let's just do a little bit of easy arithmetic right now. First of all, okay, no, let's not do it in this. Okay, I'm just gonna get a new sheet up. So let's go from 15 to like, well, we have to consider the x value that will get us to up to 116, which would be, well, 116. And then we could do all the numbers from 116 down to 57. 57 times, or 116 divided by 2 is 58. So you have to consider 58, 56, 7, and 58 as having two distinct y value, like two ranges, either a 1 or a 2. So for 59 to 116, there's one hit. Then 57 to 58, we have to consider that it works in 1 and works in 2. Now, which ones will only work in 2? Well, from 56 down to 57 divided by 2, 29. Yeah. $29 to $38. Can do it in 2 or 3. But from 39 to 56, it can only do it in 2. Is that correct? Yeah, because then you overshoot because it only reaches 116, right? Yes, okay. And then all we have to do is get down to the number 14 here, little by little, and then we can evaluate properly. So, okay, then... So... and do it in 3, and then oh, wait a second. So wait, are all the numbers from 20 to 29 able to do it in 3 and 4? The number that can do it in 3 but not in 4? Or 3? Number 38 can. Gets passed. Actually, 29 actually reaches it 4 times, so that's 28 to 30, 20, so 30 to 38. Then 29 can do 2, 3, 4. It actually bridges the gap. It's the only number that can successfully bridge that gap. So then this will be 3, 4. So 148 wouldn't work. 116 divided by 5, so up to 23. So 22 can reach in 3, 4, and 5. So what other number could return 2, 3, 4, 3, 4, and 5? Anything from 20 to 22 would work. So remember, we have to get down to 14, so we're slowly approaching this area right now. So 19 requires a minimum 4. I can go up to 5, but can't do 6. Or yes, I can do 6. Yeah, 4, 5, 6. So 20 can't do 6. But 19 can do 6. 20 can do 3, but 19 can't do 3. Okay. So what number can do 4? 59 divided by 4. 15 to 19. Well, can 15 do better? Probably. Okay, I think that the easy way is we do this. So it's 19, 18, 17, 16, 15. As now we know that 14, as we said before, 14 2 times 15. That's 205, well within the range. So, every other number here. 18 times 4, 72 will reach. Minus 4, 17 will reach. 16 will reach. So all of these guys can do it in 4. Now what's the most amount that they can do? 6. 6. 7. This can get to 7. These guys all do it in 7. Okay. So now we need to calculate all the numbers that can go from 1 to 7. Then we can do them accordingly. So there would be however many this is. Okay, no, I'm not even going to bother doing it that way. Let's do it this way, just make it easier for me. 29, 28, 22, 19, 18, 17, 15. And this can just be 29. This is 59, 7, 39, 30, 23, 20, and then those can all go away. Equals this minus this plus 1, and that's the number of things we care for each of those. So for each one, there's 60. So what we do is we do filter, but it's column 6, include equals 1, no, equals what we do is that's correct, but we do sum of that area. So now we take how many there are of each of those and multiply it by those values. So how many ways can we do it in 1? There's exactly one way to work. Well, many ways we could do it. Now we just repeat the exact same thing, but we work with these values. So can we reach minus 148 with a positive value? No, of course not. Well, actually, that's a good question. If we do it in... Yeah, so 15 steps. We start with 0. Let's just say that. We do. 15 steps would mean we reach 15 times 16 divided by 2. 120. Which isn't enough. So all these are going to have to be straightways down. Which makes this pretty easy, honestly. So let's build up from 0. Yeah, so these are all of the... This is the x's we care about. I'm just doing this manually now, mathematically. I'm not actually evaluating any of these, which I find is really funny. I mean, not quite yet. I'm going to have to evaluate them once I reach... When I have to come back to this sheet and think about those 4. But yeah, so... other values. What's the minimum value that would reach it then? Well, if we go up to 15... Oh, sorry, it has to do it in 7. Sorry, in 7. $148 in successive steps. Well, if we're doing it in 7, then it would be decreased 7 times. Minus 6, minus 5, minus 4, minus 3, minus 2, minus 1. Then divided by 7. So the number 19... Oh, sorry. So we start with 19. 20 is 1 step. 21 is 2 steps. So this is 3 evaluations. 4, 5, 6, 7. So 19 is too high. Sorry, no, 19 is perfect. Yeah, 19 is exactly the number that would do it then. So 19 is the lowest number we have to work with then. 19. All the way down to, well, I mean, minus 198 is a little bit of a stretch, because obviously we can't do them all in 1. But to do them in 7s... Yeah, let's just... Let's just go down to 200, whatever. Let's just... Whoops. Well. By the way, I'm gonna find out which song this specific song is, because it's really good. Ever Fall by Tokyo. My favorite song on this. I'm gonna have to remember that. Okay, so 1, 2, 3, 4, 5, 6, 7 steps. So it equals this. After just 1 step, that's what it is. Taking 1 step, we reach there. And then we can reduce all the way down. So now this is going to equal... Sorry, this plus this plus this. Except that red is column 6. I think that's correct then. 154. And this, not row minus 1, should be row 28. And then we drag that across. Then we drag that down. So now, we count the number of times it gets between 148 and 198. and then 198. And now it's rows number of that. So there's 51 ways to do it that way. Bam. There's 4469 non-X trivial ways of doing it. I need to find out all the ways that will get there in the trivial case, where it's going to be a little bit harder. So we start at our big value and then keep chunking downwards. So now we do it very similarly how we did before. We're going to get to 148. We start at our big number. And our big number our big number is at least a certain value, because it wouldn't work with ones. In fact, the minimum number we had to do is 19. So what's the minimum number that stalls out that long? I mean, actually, it might be a negative number. In fact, I'm pretty sure it's a negative number if we're doing negative numbers. Well, how many steps does it take? How many steps does it take before they go infinite? That's the actual question. Well, actually, it's based on the x value, right? So there could be some non-infinite values here to consider as well. We have x equals 14. Ooh, we might actually have to consider those. Let me make sure this is correct, though. Oh, actually, this isn't correct either. Because it's going to be 58 plus 57. Will get me within there. 57 plus 56. Well, okay. So these numbers are still fine. But 39 does get within range. Ah, crud. Sorry, wrong way. So 40 plus 39 plus 38 gives us 117, which doesn't hit. Remember, we gotta look at it as maximum is 116. Okay. So 30 plus 29 plus 59 is enough. 28, it's 87. Plus 26 is 113, which succeeds. Does 31 succeed? It doesn't. Well, it requires Yeah, because 4 wouldn't fit with 4. But 3 can do it with 4. Where it's 30 plus 29 plus 28 plus 27 gets you within 116. Okay, so now 29 is the weird one. 84 is correct. Oh wait, can I do it in 2? It does. That's the only one that can do it in 2. 28 still can't. Yeah, okay. That's fine. 23. So it gets to 5. It's definitely not 23 then. So 24. That's actually 25 plus 24. 22 plus 21 gives us 115. So it even works with 25. It's going to go to 26 before that ends up being a thing. Okay. I'm starting to see where the issues are coming in here. So these are going to have to go up to 14 in length, which I should have realized and was stupid not to have thought of. 25 can do it in 3, 4, 5. But it can't do 6. Okay, now 20. It can absolutely do it in 6. In fact, I have enough room to do another plus 6. I think that 22 will not work, though. So, 22 plus 21 plus 20 plus 18 plus 17. 22 will not work. It's 6. Now, 19. Nope. Nine can do it in 7. Okay. So I have to abandon all of these then. Okay. Also, this has to be 21. So, we're going to do it from 21. Yeah, just take all this. Just... I have to just, 2019. Bloop. Okay, so. Oh, that still works. Neat. That's convenient. Okay. We're gonna have to go all the way over here. Six, 7, 8. Oh, actually. Paste formatting only. Okay. So a triangle number is equals that number times that number plus 1 divided by 2 minus exactly the same thing, but you, for each of these now, also it should be column 7, just to make things easier. Each of one I want to drag. Minus 9. So that is less than equal to 116. Is greater than equal to E7. It's the same thing here. So it says 21. Reaches it. Cool. Okay, wait. So 15 plus 14 plus 13 plus 12 plus 11 plus 10, 9 plus 8 plus 7, 6 plus 5, it's 4. And 3 doesn't work. Wait, 3 does work. No, okay, so right, you remove the 3s on another day, so it should go down to 4 and not include the 3. So this sheet is now correct. Bam. But now, because I was intelligent, I only need to go to 12 for this. But now I can drag this across. I know it's going to say calc right now. But I can go from okay, so even if we start at y equals 0, we still wouldn't be able to drop down deep enough in 15 steps before you overshoot. Yeah, for any number that would go over. Yeah, any number that would go under would plummet down straight down before. Any number that goes over, which we've already calculated those. Numbers that go over that with large x values, we've already manually calculated. Any numbers that go under wouldn't reach the area or would plummet down beforehand, which we can calculate. But these guys, yeah, so we need to have a minimum. Yeah, so we'd say this is 1. Bam. Then we just drag this down. I put it to 182, which I think is still going to be sufficient. But now that drastically changes it because how many ones can get there in that range? Between 148 and 198. All these guys. Cool. There's 25. Yeah, okay. And then there's also going to be some guys that could do it in 13 steps, but that doesn't matter because no, we have no x values that can do it except the ones that go beyond. So we have 35 86s, 86 possible combinations for when our, yeah, because all these big values, anything goes beyond here, exceeds our values in every dimension. Yeah. So that is for when our x values don't go infinite. Now, we have a situation where the x values go infinite. So these guys are now done with. I've mathematically finished those. Next, 14, 13, 12, 11. And we're going to do the exact same things. Because they're all going to reach 14. Every single one of them. But now we need to go anyone that reaches at least 5, 6 for these guys, 8, and then we got to calculate numbers that go really, really high. So now numbers that multiples of them plus the triangle numbers would reach what we want. So that's the next step. So we have actually, isn't that relevant? These guys are relevant, aren't they? This guy reaches infinite here. Actually, can we just continue this? These are all the negative values. These are all the negative y's. So these guys aren't going to be useful. Actually, this guy still hasn't surpassed. There we go. And now all the values will have surpassed. Wait, what? Oh, 198. Sorry. Right? Sorry, 198. Yep. Okay. So there are these many negative values that would work for each. So these are all, yeah, so fuck it, let's include them. Because yeah, these are all the negative values I have to think about. So it happens that these guys go 15, 16, 17, 18, 19 as well. Yeah. Wait, 11 only goes up to 15? Oh, well, yeah. It's going to keep going, though, so... Yeah. We can just ignore that, because once it reaches 11, it's stayed at 0, so I'm just going to keep going. But now... This keeps going up. Ah, crud. Okay, like this. That's fine. $15, $16, $17, $18. All the way out to here. -2. There we go. So for negative y, for negative y values, these are all the ones we have to consider. That's all of them. Now we can start thinking of the positive y's. Because positive y will always go infinite. So how many positive y's will fit? Yeah. So now, all of these will always take a minimum of 14 steps to get there, by just definition. Oh, we might actually want to consider 0 as well. Let's call it non-neg y. So, start off with equals 0. We're going to go all the way up to a y value of 198. Sorry, plus 1. These are now... Yep. Whoops. It's just above 200. Yeah. 198 is the highest one we could possibly count for. Now, we are going to do... this is y, and there are going to be steps below. So, this is going to be 1 step equals that plus 1. These numbers are going to be getting larger each time now. Whoops. Sorry. There we go. So it starts off by equaling that. And now we're going to say equals this plus this. We're going to call row column 1 plus row 4 column minus 1. Every single time. So it's going to go 1, then it's going to go 3. We're going to go all the way up there, up until the number surpasses. And then we can also figure out as to how many steps it takes to get there, which we can evaluate afterwards. But this is beyond the point where they go infinite. So all of these we can math out as successfully hitting on our infinite loop, because we now have an infinite number of x's to work with. It doesn't matter whether it's before or after or how many steps it takes. All that matters is that we get there beyond the point where we go infinite, which all of these do. So now we just do we count in that range. Actually, no. I'm going to do it like this. Yeah, let's just do it the correct way, I guess. Ugh. Was it 148? And then we do rows of that. And then we spread. So none of these guys add up nicely, which is to be expected. Some of that. There were 4 numbers that did it, so 728. Whoops. 728 plus 3893. That should be the number of possible combinations. It's not the right answer. Oh, crud. Oh, no, this is wrong. Okay, no. I know why. I know what I did wrong. Okay. Well, for this one, it's going to be fine. It's for this one that we're going to have an issue with. Times, and say, hey, did you do it in one step earlier? So now we say that that range is less than 148. Because, or yeah, not less than equal to, it should be less than 148. That should actually fix the problem. Now, because what we're doing is we're double counting a lot of these, because 0 will always hit in this range, but we're counting it 3 different times. There we go. That should be correct now. So it's 142 times 4. $3,893. That's our number. Really? That's not the right number? Oh wait, did I do it again? I did do it again. I've got to do literally the exact same thing. Because the number's always going to hit. This just makes sure it's first within its district. So here, we know that a 1 will successfully hit eventually. Yeah. Okay. That's 3663. Okay. That's gonna be great. Okay. So I've now figured it out. 142 times 4. That's 3663. 4231. And I'm done. No. Ugh. Why? Why is that wrong? Because for all the positive values, it will go up, then down. Oh, wait. What did it actually say? Yeah. Okay, you know what? I'm just going to come here. I'm going to do a quick thing right now. I'm just going to come here, and I'm going to say that it is 57... 116, 148, 198. That's low X. That's high X. That's low Y. That's high Y. For each of these, I'm going to rewrite the whole formula to work properly with, instead of 198, working with high Y. Low Y. Should make literally no difference for any of these right now. This is high X. Low X. All the way up here, please. All the way across there, please. Except... Wait, what? Oh, no, okay, so... That's deleted. And then anything that's 14 or above, we overwrite numerically. because they just do work beyond there. Now we repeat with this. Yeah, so like each of these are being multiplied by 4 because there's 4 ways to do it. A 148 is the low y. That's the high y. This is the low y. This is the low y. That's the high y. And now we troubleshoot. Now we can use these values here in the sample 2030. Well, I should probably put this here and say if error. There we go. That fixes it. Perfect. Oh, but I want to go all the way down in order to count those now. Okay, let's see if there's... Yeah, so that many that would land there in exactly one shot. This groks correctly to me. This reads well. Is it this that I'm screwing up somehow? These should only now be counting the number of times that they are within that range, and also not... And also the previous one was not within that range, because the only way it can come is from below, or from above, I guess, technically. So yeah, this goes from 198. Wait a second. Just using my brain for a second. There should obviously be 51 that work. And then I expect it to be half... yeah, so 51 divided by 2 is 25. 51 divided by 3 is 17. 51 divided by 4... 13 susses me off. Okay. I know it's not exact. It is inclusive, right? Because it'll do the whole up and then the whole down. Oh, wait a second. No. We literally talked about this before. Oh my god. Because when it goes a whole up and then comes back down, it hits there at the 0 and then goes a step below on the next one. Oh, I'm dumb. I'm pretty sure this is going to be correct now. 4227. It's not the right answer even still? Okay. I'm troubleshooting and drawing blanks. I didn't put the check in here, right? Yeah. And this range would be 35? That doesn't feel right. Freaking stupid. I don't know why I didn't go all the way down. Like, I'll even said before, I need to go to at least 200. I don't know why I didn't. I'm just seeing so many little troubling issues in all of these here. Let's just save some time. It doesn't matter. This will evaluate the same as before. Oh my gosh. Whoops. It just is 4623. Okay. And done. Oh my god. Yeah. The first time I've had to do a 5-minute timeout. So many bugs in my spreadsheet. Okay, well, let's actually just check. At the 5187? Yeah, okay, yeah. So at my 1 hour, 30-minute exactly timer on my OBS is when I'll... a minute 45, so I have to wait until 1:31:45. Which means if this is correct, then I lost the 90-minute point by pulling a hare instead of a tortoise. Oh my god, I can't believe it. How stupid of me. This is going to be one I'm going to really enjoy refactoring to get it to work. I'm pretty sure, like, this is one that I am essentially doing by hand. Another one that I'm doing by hand, but... Have you guys been enjoying the series? I hope you guys have been enjoying it. I mean, I'm now 17 days into getting 2 stars. I mean, I hope I am. I hope I'm 17 days into getting 2 stars. But we're gonna find out in a little bit if I still have to go back and do even more. I can't possibly think of anything else I missed, because this went all the way down past 200. Yeah, to 198. That's the deepest I could possibly go. That will overshoot, so I even included one that overshoots. All the other ones are there. Yep. I don't even know how I don't even know what I could do now. Like, I can't figure anything else that I'm missing. Like, all these other numbers already reach. So there's, like, nothing else I could do. This already reaches. All the other ones will fail. This adds it up correctly. There's exactly 60 numbers of difference there. So 16 done 10 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But if you do another one, it surpasses. $16 can do it in 4. Yeah, of course it can. 16, 15, 14, 13. Yep. So yeah, there's 15 ways for the x to be 4, or for the number of iterations steps needed to be is before. Because all the numbers from 16 to 30 do it, which is 15 total numbers. I didn't miss any crossovers, right? 59, 58, 57, 66, 31, 36, 30, 32, 20. Yep. This is all correct. Let's just check something. Let's sanity check. There's 141 values that can reach there. So there's a lot of values that can't. Surprisingly, it's like a quarter of them can't. $5,187. That was definitely what I put in last time. These are all negative numbers, by the way. So this is the negative y area. Okay. Maybe I just have to do a full refactor. A refactor. So, we're going to do a whole host of all of these. We're going to count how many ways we can do each. I mean, it's 60 divided by 2, divided by 3, divided by 4, divided by 5, divided by 6, divided by 7. To reach here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So this should now be, wait, what? 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So this is where that should drop off. It doesn't, because it stays going down 0 forever. Oh my gosh. Yeah. Well, so steps 1, 2, 3, 4, 5, 6, 7, 8, 9, 11, 12, 13. So in exactly one step will be any number that is, so yeah, this is lower bound, upper bound. So it will be ceiling of so 57. And then stuff changes afterwards. But now this is going to be it's going to be 4 pi x divided by this. Significance 1. So equals this minus this plus 1. Now let's just check for sanity check. Whoops. Uh-oh. Did I make a mistake? Is this what my mistake is? 18? Can 18 not do it in 8 steps? 18 plus 16 plus 15 plus 14 plus 11 equals 116. 11 not do it in 8 steps? Then why is that 8 but that's 7? This doesn't do 8 to 14. Because it doesn't know that 8 wouldn't reach there. 8 plus 7 plus 6 plus 5 plus 4 plus 3 plus 2 plus 1. Yeah, 8 doesn't reach there. was 10 to 13, right? No, it was 11 to 14. Let's double check and do 10. $55, no 57. And then I can keep going, actually. So now I have the number of x's. I think once I get to like 5 or something, I know that that's sufficient. And now I can do number of y's, where I evaluate y up to. Honestly, I only need to do 7 steps. That's really all I need to do. Oh, this is wrong. That's why. I need to do the triangle number. Yeah. I could do the quadratic formula. I think I can pretty confidently say that this is just correct. So as such, I want to cheat. Or whatever. There we go. Whatever. Like, I don't understand what else I could be doing wrong here. Like, every other value, 13 and above, we multiply by 4. Yeah, that was the only hiccup. Everything else lines up really nicely. Which I find interesting that it doesn't line up perfectly. I wonder why it doesn't line up well. Maybe it's just that it's not supposed to line up well, it just happens to line up for these numbers. Whatever. So, the first step is going to, so these are all the negative y's. So the first step is going down by 1. Then you go down by 2 more. Then you go down by 3 more. Then you go down by 5 more. All the way until you reach here. Bam. And we'll just drag all the way down. 200 to whatever. Okay. Now, there's 51 numbers, which intellectually feels correct to me. That fits there. There's 25 numbers that fit there. Then there's 17s, 13, 8, 5, 4, 2s. Yeah. 1, 2, 3, 4. Exactly 8 steps. Well, if it's exactly 8 steps, then it would be 7 plus 6 plus 5 plus 4 plus 3 plus 2 plus 1. 28 higher than it should be, so 120 to 170. That's correct. And then this number 2, this number 2, number 2. But then the other ones don't. Yeah, the other ones don't because those were already done last turn. I don't understand why this is wrong. And these are, of course, going to be 0 because there's just no values there. It just makes sense. X values less than 11 don't make sense. X values bigger than 116 don't make sense. All those X values have been successfully encapsulated here. I for the first time since I've started, I'm genuinely stumped on what I did wrong. Genuinely and wholly. Because every other number does it and move 17 steps beyond when they hit the middle. Because it doesn't matter how many steps you do here afterwards. Because all we know is that it's going to be a number of steps beyond, in this case, what is it? Yeah, beyond 12. Because 12 plus 11 plus 10 plus 9 plus 8 plus 7 plus 8. Oh. Do I have like another case or two to consider? Yeah. Yeah, these are the X values though. Looking at Y values, yeah, 12 plus 11 plus 10 plus... Okay, no. 12 plus 11 plus 10 plus 9 plus... Oh my gosh, are you kidding? 12 plus 11 plus 10 plus 9. 78. Not high enough. So any even neutral nugget, any number that's 0 or higher, will, by necessity, by necessity, not reach the minimum Y value yet, which is 148. Any number has to reach at least 17 full steps before they reach, which is exactly the amount of numbers that 0 does it in. 17 steps. But any of these values will all only have 4 X values to care about. Yeah, 10 is insufficient. And 15 overshoots. Yeah. So 15 requires... Yeah, 15 requires... It needs to be in over fewer. And any number that's positive requires 17 or more, so there won't be an overlap. Wait a second. Yeah, no. Because These guys all reach the threshold point at 8. I was like, maybe they don't reach there in time? No, but they do. They absolutely do. I don't understand. What am I missing? Like, I genuinely just don't get what I'm missing. There's 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, from here you go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It'll reach here, then go 10 or fewer. 9 is the highest it would go. Yep. Oh my gosh. Yeah, the first step gets it to... Yeah. We have 14, then the next step will bring it to 15. Yeah, I don't get it. I don't know what I'm missing. Like, this just completely make... Like, this... I understand the concept of this problem. I don't understand what I fucked up. Uh-oh. Go back to Sessions Diana. Go back to the song I really liked. All y values above will just surpass. All smaller x values won't work. All bigger x values won't work. We're only stuck with those 4. Because 10 doesn't reach it. Five is still within the... Yup. Doesn't get there, doesn't work. I genuinely don't understand what I've done wrong. This doesn't make sense. Like, this feels correct. I can't figure out, like, there has to be some kind of implementation, something that I did wrong. This passes my sniff test. I genuinely don't get it. Okay, let's sanity check. What do I want this number to be? Starts at 1, goes to 106. This number should be 106. It is 106. Yep, 30. 20. 15. 12. 10. 8. 8. 6. 6. 5. 5. 4 across the board. Yeah, this is just right. I don't understand what's wrong. Both of those good last time. Those guys got it this time. Let's just sanity check. Like, this all adds up. Or 47 doesn't reach it. Wait a second. No. Wait a second. Oh, crud. Oh man, wait a second. Wait a second. I understand now. I now understand what I did wrong. So, here I was saying, oh, well, 2 does it in this many steps. And so it must be exactly this many steps I care about. But it also is in this many steps. In this case, they happen to be the exact same numbers. That's not true of the 12s. So this is 17, 16, 15, 14, 13, 12. So these guys, this and this counts all these numbers as this. Oh no, it's these guys. Oh. Oh my god, I recognize the problem now. I've got the numbers of each value and not the next. Yeah, unique digits. Because if it hits a 57 at all, it doesn't matter whether it does in 1 or 2. Okay, so I now understand. For these numbers, it's always going to be times 4. But I ignore... Okay, holy cow. That's actually so much trickier. Okay. Wait a second. Can I not just... Numbers I care about are 11 to 116. Whatever, I don't know what 116 would be. Doesn't matter. It's 116. Delete. We go from here all the way back to here. Hide. Okay. I think I figured out. So these are going to be negative numbers. 1. And then we're going to bring them all the way down to 200. So, what I'm going to do is I'm going to say... Oops. Okay. Let's go all the way down. Let's just go to 200 for simplicity. We'll come down to here, scroll all the way back up. I figured out an idea. So, okay, so a number, I think I can do this in a single table. So we gotta figure out the triangles of each. So, okay. So, the x file is what we care about. So we have to get for the first 4 digits, which by the way, I'm just gonna... Oh no. Whatever. Unhide. I don't care anymore. Doesn't matter. Okay. Let's go take away these guys just to make them a little bit cleaner to work with. There we go. So, these are all the possible combinations we could possibly be looking at. We need to see whether there's a world in where, first of all, this is for negatives. Then we're going to do the same thing with positives afterwards. No, we don't have to, actually. Okay, wait a second. 200 minus 1. Bam. Okay. So, if the number is greater than, then we just say if it hits. So, how do we figure out if it hits in one hit? Well, we take... Sorry. So this is 11. So for positive numbers, we really care about these guys. Because they're the only ones that actually matter. So, how do I check non-negatives? Nope. It's the triangle value numbers, right? How do I figure out if there is a triangle number? I have to use a quadratic equation. I can do this. I just gotta think. How many steps? It's one step. So that's how many steps we get. And now we can use that equation to say I think this is correct. This looks a lot more correct. This looks actually exactly correct. So that's V. Yeah, so this is one step. No, it's not right. This is the one where we do. Okay, it's not straight division. I need to know the number of steps I need to get there. But we have A times A minus number of steps equals pi y. That'd be A squared minus AN equals pi. We have A as 1/16. Pi y minus A squared all divided by A, HY over A. Sorry, it's not equals high I, it's less than equals to high y, so this is all less than, so. Let me say that. So now we have AN is greater than a minus hy over a n is greater than a, so 1 minus y. Why is that hy divided by... We have AA minus HY. Then we have unless you do 2 steps. Unless you do... This isn't unless you do... What? This is unless you do 2 steps? That's wrong. This went too low. Which it didn't. Yeah, so this should be letting you do... That's wrong. Okay. Yeah, this is not right. Okay. This is just screwing with me again, so... we have a times a plus 1 divided by 2. All of that minus, let's do this in a notepad. So that's the number that we're working with. We want to solve for n when we know a. That is below. We're going to call that y. So, first step, multiply both sides by 2. Next step is to expand. So it's going to be a squared minus na plus a minus na minus n squared minus n plus 2y plus a2 plus a minus a2. Oh, that's actually going to cancel out. Plus 2na plus, so minus a plus n squared plus n. So the a2 cancel, yeah, that is plus 2y. Cancel out the a's, that's one a gone, that's an a gone. That's gone. So we have n squared plus 2na so yes, we have n squared plus 2na plus n. So you factor in n. We have n squared plus n times 2a plus 1. Okay. Then, oh gosh, today's gonna be another really tough day. Having a couple bad assumptions just throws the whole thing out the window. So we have quadratic formula 1, 2a plus 1 y. And then this will give us the n values that equal 0. So, we want the so be x is equal to negative b plus or minus the square root of b squared minus 4ac all about 2a. Well, A is 1. Like that. These are going to be positive numbers. Regardless, this will be a positive number. Well, if it's minus b minus a positive number, that would make sense. So it has to be plus. So if the numbers exist, which it would be for I think all of these, then we're looking at minus 2a minus 1 plus square root of 2a plus 1 squared minus 8y. And that should give us, and then I think it'd be floor. Okay, so let's just try this. Where A is row, column, square root of I mean, the numbers would be even lower, yeah, right? Let's remove floor and see what we get. This is going to be chaos. Wait, what? Yeah. But this gets n minus 3, yeah. Because this looks right? So, where we have the triangle number for this. So, 116, 115, 114, blah, 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 all the way down, minus the triangle number for some number lower than it. In this case, what we're looking for is, yeah, in what case we're looking for n equals 1, roughly, where We subtract all the other ones, divided by 2. Actually, 3.42 might actually be the breakpoint. That's the problem. I just don't know what the intervals are. Oh, that doesn't help at all. Because it rounds. The rounding is significant. How do I modify this so it works? Okay. Here, let's start with this. Let's just do a conceptualization. Let's do conditional formatting, manage rules. Format them so that they're gray. What? There we go, okay. So for these guys, we need to count all of the numbers. So do I erase this? So I need to figure out a way to be able to apply this correctly and math this out correctly. Oh, wait, is it like... So I have like the numbers 10 and 11. What it'll see is it'll go up and say, hey, this value here only works on the value 10 or 11 or whatever the hell. With a wide array of this, and then say, well, how many unique 10s are there? Okay. I now understand. Okay, so this is starts. There's exactly one start in this column. There's two starts in this column, one start, one start. And then the totes of numbers that are included but aren't the first, meaning it could be anywhere up there. So this is your first 11, you count all of these. But if it's not your first 11, you only count. You don't count any of them. So if you're 11, but it's not the first one, yeah, then you if you're on step 11, but it's not your first one, you just completely skip that. But if you're on 7 and it's on, or if you're on 6 and it's not your first one, you just count these guys. So you've counted all of those. Should we count actually blowers? If it is your first, you count those. Yeah, no, if it's your first, you count the whole thing. Whoops. Uh-oh, wait, what? Oh, I guess that would make sense for a couple of these. Okay. Now we come here. Okay. Take all this. We're just gonna bump it up by 1. There should be no issue here. We're going to insert. Yeah, this will fix it. Huh. Whoops. And this is row. Sorry, column. There we go. That's 58. That's correct. Perfect. Oh well, and then we do if error 0. Otherwise, you pump out the number. Okay. So now, if it's your first time, you pull that number. If it's not your first time, you pull that number. I need a couple more. Oh, come on. Okay, okay. That's just for the positive numbers here. For the non-negative wise, you have to do a similar thing. So no issue. Same thing as before. Sorry. Then minus that should be 0. Oh no, wait, no matter what. It doesn't matter if it's their first or second. It makes no difference in the positives. Oh, come on. Is this gonna be right? Oh my gosh, I don't know. I don't know. I don't friggin' know. Because now it's saying all the times that it's being in this column, we've already seen it before. Oh wait, no, I did this backwards. Since I've seen it before. So this should be column -1. numbers. So if you've already had one before, yeah. Okay, 5200 flat, so what it says here. So, just to fix this, so this, numbers 28 to 29, hit the value 6, and there's 3 different values at the number 6. 3 total values at number 6. And it says, hey, for 6, there are 2 new x values you consider from 5. You do 2 times 3 makes 6. 4636 number is 5200. And it's not going to let me because it's going to say I'm on a 10-minute cooldown. Okay, 5-minute cooldown, that's not too bad. But I think... Oh man, this is just... I don't want to have to refactor the whole thing. But yeah, I'm now understanding that. So, when I'm looking at these numbers, there are these numbers total. 1, 2, 3, 4, 5, 6, 7 to consider. But there are 4 that have never seen light today. So since there's 4, we look at here and say, well, how many total 7 values do we have to consider? Okay, so there's all those together, and there tends to be 8 total numbers, so it's 32. So it's an additional 3 on 7s that were already counted before. However, all the values are already counted, so it pumps out 0. To logic check the exact same thing, for there were 2 extra values of 6. I can't say, okay, the number is 5200. I would put my money on this now. I've got a minute 55 left to wait. Oh man. God, this has been a ridiculous problem. There's been like 15 individual issues that have all come up that make this is me like putting my mathematical ancestors to shame, kind of thing. Oh, this is bad. I don't know how much time I have left. Minute 18. Okay, 41:30 roughly. Oh, let's just make sure. Well, I've got this time. I may as well look at here. There is 1 fresh number. There are 2 old numbers. This does nothing. Where's the first time that it actually gives me some value that actually matters? Here. On the 8s, yeah. So on the 8s, there are 2 numbers that are new. Sorry. Where's the 8s? Here are the 8s. There are 4 numbers that are old. There are 4 numbers that are old. And you multiply by the number of total 8 values you have here, which is 8 to get 32. There's also 3 old values. Multiply by 1, because there's only 1 new value, gives you 3. Yeah, okay. Let's have another 20 seconds to go. It's gonna say, what, 15? 14. Okay, so I can do it on the 20, on the... Oh, please be done. Please be done. This has been... a mathematical trek, and I do not wish to continue playing any further. Oh, kill me.